All right, today we're going to be talking about probability distributions. So we're going to do some random variables in computing probability, and we're going to talk about probability distributions in terms of real-world problems. So the only thing that we're really going to talk about is the probability distributions and probability histograms. All right, so let's take a look at a couple of these. So here's one that's listed more like a frequency table as opposed to an actual probability distribution. We'll get into a few of those in just a minute, but they come off of these. So here was a survey. A pet store asked about their customers, how many pets they have. So 3 of them said 0. Maybe they're buying something for a friend or something. 37 said 1, 33 said 2, 18 said 3, and 9 said 4. We want to find the probability that a randomly chosen customer has at most 2 pets. So when it says at most 2, that means 2, 1, or 0. 3 or 4 are not values that we want to add up. We'll need to add up these. But before doing that, we need to find the total. So what needs to go in the denominator? To find the total, we're going to add up all the different customers. That's how many different customers that they had. And so by adding those all up, we're going to get 100, which of course makes the rest of our percentages really easy to figure out. So now we want to find at most. So the numerator is going to be these 3 numbers added together, which is 73. 37 and 3 is 40. 40 plus 33 is 73. So those that are at most 2 is 73 out of 100, or 73%. So most of their customers have at most 2 pets. All right, let's use the same one. What if we want to focus in on those that have 2 or 3 pets? So we're going to take these 2 amounts, add them together, 33 and 18, getting us 51. 51, again, still out of that 100. So 51% is has 2 or 3 pets. All right, a survey was conducted concerning the number of movies people watch in a theater per month. Again, this is the total number of people over here. If we start adding this up, it does, that's 40 plus 30 is 70, and another 30 is 100, so it does add up to be 100. Find the probability that it randomly watches at most 1. So we're talking about these 2 combinations. So if they're at most 1, they're just 1 or 0. Adding those together, and we get 30, and 30 out of 100 is just 30%. Doing this again, 0 or 4, so that's 7 or the 11, add those together for 18%. So let's talk about a probability distribution. There's 2 rules. The probability of each value is greater than 0 or equal to 0, and less than or equal to 1. So it's between 0 and 1. There's no negatives, and they're all decimals. What's the possibility of all of them have to add up to be 1, though? We have to have 100%. So those are the 2 rules in order for us to have a probability distribution. So let's take a look at this chart here. Here's the distribution for the grades. 9th grader, there's 0.29% of the students are 9th graders, 0.26 is 10, 11, and so on and so forth. Show that this distribution is valid. Well, first thing we have to do is look at all of our numbers, make sure that they're between 0 and 1, and all of them are. The second thing we have to do is make sure that they all add up to 1. So 0.29 plus 0.26 plus 0.25 plus 0.2 does equal 1, so we're good. This is a probability distribution. All right, since we know it is, what's the probability that he or she is grade 11 or above? Now, the nice thing about this, the way that it's laid out, is we're just going to add 11 plus the 12, so the 0.25 and the 0.2, giving us 45%. 45% of the student body are upperclassmen. And that's pretty typical, actually, for a high school. Now we can make a probability histogram. That's just a histogram, remember, is kind of like a bar graph, but it's usually on the bottom here. I'll show you in just a minute. So we're going to go ahead on the side here. We're going to go ahead and have our probability going from 0 probably up to like 0.30. And then on the bottom here, we'll have our 9, 10, 11, and 12. So 9, 10, 11, 12, we go from 0 up to, like I said, 0.30. And we just have a bar graph. Now, you'll notice here that there's quite a few more freshmen than there are seniors and such that. But this is your histogram. I'm not a big fan of this little break here. I'd much rather go from 0 to 0.30, so you have a better, that makes it appear that there's significantly less seniors, but that is how they wrote that graph. All right, the table shows the probability distribution of the number of children per family in Maplewood. 11% have no children, 23% have one, so on and so forth. What's the probability that they have at least 2 children? So 2 or more. So we're going to add up all of these. 32 plus 8 is 40. 40 plus 26 is 66. So then we're going to go ahead and look at the histogram of that. So we got to go back. 32 should be the highest, so the middle is high, and it gets a little bit less on each side and even less on the farther side. So this is most definitely A here. That one's all the same. This one's getting bigger. They're saying 4s, and this is boom, 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 boom. None of those really fit except for A. And that's what I have for you today.